Before proceeding with the installation, configuration, operation, or maintenance of these products, please ensure you have thoroughly reviewed all relevant documentation provided by Balluff and other pertinent sources, including installation guides, configuration manuals, and operational protocols. It is essential for users to adhere strictly to all applicable codes, laws, and safety standards during installation, wiring, adjustment, and operation. Installation, configuration, use, assembly, disassembly, and maintenance of these products must be performed by individuals who have received appropriate training and are fully versed in following the outlined procedures and safety measures. Failure to comply with these prerequisites may result in noncompliance with legal and safety standards. We expressly disclaim any liability or responsibility for damages, whether direct, indirect, special, or consequential, arising from the use or application of the information contained herein. Balluff Inc., in no event, will be held accountable for any damages incurred as a result of using this guide. The content of this guide is intended for illustrative purposes only and does not ensure suitability for specific applications due to the diverse range of variables and requirements in different scenarios. Users are entirely responsible for verifying the applicability and safety of this information for their unique situations. Acceptance and use of this information come with an understanding that any and all risks associated with the installation, configuration, assembly, or use of these products are fully assumed by the user. Please note that this document does not serve as a warranty of any sort, nor does it modify or supplement any valid warranty provided by Balluff Inc. for these products. The information herein supplements the original warranty terms without altering them.
The input buffer is described as seen in the configuration manual. First, we need to map every byte and bit that is important to interface with the sensor. In byte 0, we will find 3 status bits, waiting for trigger, result data available and ready. In byte 1, we will get any system error. In byte 2, we will have job start, job end, job error, and the toggle bit TO. This bit is used to get the next batch of data, when we are expecting a string that is larger than 30 bytes. In byte 3, we will get a command status. This byte will tell us if the job was carried out correctly. Now, for the output buffer, we will have 2 headers, one in byte 0 and one in byte 15. Note that these 2 headers need to be changed at the same time on any given operation. In bit 0 of the headers, we can trigger a job according to the command assigned in byte 1. In bit 1, we will find the trigger. This bit will trigger an inspection on the sensor. By toggling bit 2, we can reset any error, and in bit 6, we will find the toggle bit TI. This bit is used to get the next batch of available data. As said before, in byte 1, we can assign the job type the sensor is going to perform. 0x03 is a command for getting results from an inspection into the PLC. When the sensor is triggered and results are available, if we trigger a get results command, the sensor will populate the input byte array as described in the table shown. We will get the first tool result in byte 10. This will be a FF if the tool was successful or a 00 if the tool was unsuccessful. Starting from byte 11, we will get any additional values. In this example, we will get the value read from a code. We will also get the inspection ID in byte 6. To map these bits in bytes, we can create aliases. It is recommended to create all of them in one go, as shown in the video. We start creating the aliases for the input bytes. We continue by creating the aliases for the output bytes. Remember that both byte 0 and byte 15 must have the same value at all times.